Welcome to this presentation on understanding attention mechanisms, presented by deeplearn. Moving on, let's unpack the core concept of attention mechanisms. At its essence, attention enables models to weigh the importance of different words in a sequence, regardless of their position. This is particularly crucial in tasks like machine translation, where the meaning of a word can heavily depend on its context, which may be far removed in the sequence. Traditional recurrent neural networks, while powerful, often falter with long-range dependencies because they process input sequentially. This sequential nature creates challenges in capturing relationships between distant words. In contrast, self-attention in the transformer architecture allows for simultaneous consideration of all words in a sentence, achieving a constant time complexity. Imagine you are reading a long sentence. Instead of processing word by word, you can reference the entire sentence to understand the meaning of each word. This shifts the paradigm in how we handle sequence data, leading to improved understanding and translation accuracy. Now, let's break down the architecture of the transformer. It is composed of an encoder-decoder framework, where each section is built from layers that utilize self-attention in unique ways. The encoder comprises multiple identical layers, each featuring two sublayers, a multi-head self-attention mechanism and a position-wise feed-forward network. This dual structure allows the model to capture complex dependencies within the input data while maintaining a streamlined process. On the decoder side, there is a third layer that performs attention over the encoder's output. This is crucial for ensuring that the decoder can utilize the entire context provided by the encoder, effectively bridging the input and output sequences. Visualize the encoder as a robust filter that processes and compresses information, while the decoder acts as a generator that leverages this processed information to create meaningful outputs. The synergy between these two components is what facilitates the impressive capabilities of the transformer. Let's delve deeper into the concept of multi-head attention, a cornerstone of the transformer's effectiveness. Rather than performing a single attention operation, the transformer uses multiple attention heads. Each head is a separate attention mechanism that processes the input in parallel, allowing the model to focus on different aspects of the data concurrently. This diversity in attention heads enriches the model's understanding, enabling it to capture various contextual nuances. For example, one head might attend to syntactic relationships, while another focuses on semantic meanings. By concatenating the outputs of these heads and processing them through a final linear transformation, the model can synthesize a more holistic representation of the input. Think of it as having a team of experts analyzing a complex problem from different perspectives. The collective insights from these perspectives lead to a more informed and accurate outcome. This multifaceted approach is what sets the transformer apart from its predecessors. Finally, let's discuss the performance and broader implications of the transformer architecture. The results speak for themselves. The transformer has achieved remarkable BLEU scores in translation tasks, surpassing previous state-of-the-art models, even those that utilized ensemble methods. An equally compelling aspect is the efficiency in training time. The transformer can be trained in just a fraction of the time required by traditional models, thanks to its parallelized nature. This not only accelerates research and development, but also makes state-of-the-art performance more accessible. The implications of this architecture are vast. Beyond translation, the transformer is poised to revolutionize various fields involving sequential data, such as text summarization, question answering, and even image processing. As we consider the future, think about the potential of applying this model to other modalities like audio and video. How might that change our understanding and processing of complex data? As we wrap up, let's reflect on how this architecture not only changes the landscape of natural language processing, but also opens doors to innovative applications across disciplines. Thank you for engaging in this exploration of the transformer with me. Thank you for watching this presentation.